Okay, in geometry there are two special right triangles, okay? The first special right triangle is what's known as a 45 degree, 45 degree, 90 degree special right triangle. So here's what it would look like. It would be an isosceles because if this angle is 45 degrees, then this angle has to be 45 degrees. So that means that these two sides have to be equal to each other because it's an isosceles right triangle. So here is the part that's really important. Whatever this side length is, let's call it x. Well, then this has to match. And it turns out that the hypotenuse of a 45, 45, 90 special right triangle is whatever your side is multiplied by the square root of 2. So here's a little map. To get yourself from a leg of the special right triangle to the hypotenuse, you multiply by the square root of 2. To get yourself from the hypotenuse back to a leg, you divide by the square root of 2. So as an example here, well, if this was a special right triangle at 45 degrees and 45 degrees, if this was 3 and 3, this would have to be 3 rad 2 because we multiply by rad 2 to get there. A harder example is one that looks kind of like this. Okay, if I told you that this was 7, 45 degrees, 45 degrees, 90, well, what the heck would those be? Well, to get yourself from the hypotenuse back to a leg, you need to divide by the square root of 2. So I'll take 7 and divide it by the square root of 2. But unfortunately, I have a radical on the bottom. I'm not allowed to leave it like that. So what I need to do is rationalize the denominator by multiplying the top and bottom of the square root of 2. Because after all, that's just a really fancy looking 1. So I'm not changing the value of my expression. So that's just going to be 7 root 2 divided by the square root of 2 times the square root of 2 is just 2. So that means that this is 7 square root of 2 over 2, and this is 7 square root of 2 over 2. Okay, so that's the first kind. The second kind of special right triangle in geometry is what's known as a 30, 60, 90 special right triangle. And it looks something like this. So let me give me some room here. So if I have a right angle here, this angle is 30 degrees. This angle is 60 degrees because 30, 60, 90, I have to add up to 180. Okay, so here's how I label this, right? I label this the hypotenuse, of course, the longest side. Then I label my two legs. I have a long leg and I have a short leg. Okay? So we're going to start with the short leg. The short leg is whatever it happens to be. This is called x because it's a variable. It's going to change from problem to problem. It's going to be x, okay? Well, it turns out that to go from the short leg to the hypotenuse, you just double it. It's just 2 times x, whatever that happens to be. And to go from the short leg to the long leg, you multiply your x by the square root of 3. So here are your special ratios that always seem to work. Or not seem to, they do. So x times 2x, to go from the short side to the hypotenuse, we multiply by 2. Now to get yourself back, to go from the hypotenuse to the shorter side, you divide by 2. To get yourself from the short side to the long side, we multiply by the square root of 3. To go back, we would divide by the square root of 3. Okay? To get yourself from the long side to the hypotenuse is kind of difficult, but we can still do it. So here's a couple of examples for you. Okay? Here's a 30, 60, 90 special right triangle. And if I told you that that this side was 5, the short side is 5, how do you go from the short side to the hypotenuse? Well, you multiply 2 times 5, so this has to be 10. How do you go from the short side to the long side? You take 5 and you multiply it by the square root of 3. So that has to be 10, that has to be 5, that has to be 5 times the square root of 3. Alright, let's try another one here. What if I told you that this was 7 down here? Again, 30, 60, and 90, okay? Well, to go from the long side to the short side, I need to divide by the square root of 3. So the short side would be 7 divided by the square root of 3, and again, I need to multiply top and bottom by the square root of 3 to rationalize it. So I get 7 square root of 3 over 3 for the short side. Then going from the short side to the hypotenuse, I multiply by 2, so I take 2 times 7 square root of 3 over 3, which is 2 times 7 is 14 square roots of 3 over 3. And there is your answer for that one. So two special right triangles. We have a 45, 45, 90, and we have a 30, 60, 90.